And the recording has begun. So I'll just run over what I said just so we have it on the recording. Basically, we're going to start by looking at our GitHub, the GitHub repo that's called Schematic Altium Library. So I'll share my screen. So this is the GitHub repo, and when you to get access to libraries, everybody clones this repo, but then you only care about everything that's in the integrated libraries folder. But those integrated libraries are compiled from a database library, so that here in this, all the other stuff that really drives the compiling of the integrated libraries is found under models. And you can see we go under PCB footprints, there's a ton of files for footprints. If we go to schematic symbols, there's a ton of files for different schematic symbols. And then you have a .dblib file, which specifies specifies the linking between the database. In this case, we're not using a database, we're actually using an Excel sheet, and the .dblib handles the conversion to a database. And this db.xlsx, that specifies the logical linking between schematic symbols and PCB footprints. Then you will, in Altium, you'll compile the dblib into separate integrated libraries. So then these are binaries that we distribute out to everybody. Well, we distribute it through the GitHub, but it could be distributed by other means as well. When we're in Altium, you can see here I've opened up our Schematic library.dblib. And if creating this file from scratch is pretty easy. All you have to do is you will create a new .dblib. You select that database type, in this case, it's an Excel file, and you give it the path. And it's convenient to have the path here relative to database library, so that you can, so that basically you can store, well, let me show you, you can store the db.xlsx just relative to the path of this. So that makes it convenient for anyone who's going to compile the libraries. Let me just hit reconnect there. So the Excel sheet that backs everything, I've got it pulled up right here, and it's separated into sheets, and each sheet has a different name, and every sheet will get compiled when you make the integrated libraries, will get compiled into its own integrated library. And it's the fields, or it's just like it's just like a database, except it's a spreadsheet. And Altium handles the conversion, like I said, between the Excel sheet and the database. So we could, and in the past, we actually distributed the libraries as a database library. So everybody was working from their own copy of all the database files. And the reason we moved away from that was mostly because it involved one extra step, which was that you had to have a Microsoft Access database engine installed on your machine, which really wasn't a terribly big deal to do it, but it was an extra step. And there was also just the source of confusion, because then Altium had to compile a database or build your libraries from a database every time you ran something. And this just seemed a little more organized, and to basically compile them to integrated libraries. And then you can distribute those integrated libraries in any way you want, via Google Drive or Dropbox, or put them on a flash drive and hand them out, whatever. Obviously, you wouldn't do the last one, but So at this point, here's the sort of workflow that you would go through. If I had a new part to add, somebody give me a part number that isn't in the library that you don't think is in the. I mean,
oh man.
Sorry, I mean, I don't know. What do we want to add? We could add like
what are cool parts?
Yeah, one that we don't have, maybe we should have, is like the TL082 or something. We could add that. That's an easy example. We'll add the TL082. I don't think we have that. And I believe that's available in an SOIC 8. We're just gonna Google it and why, man. Okay, so let's just make sure that this is in fact available in SOIC. I know what the pinout is already, and it is. Yes, it is. So now we just need the part number for that, which would be the package. Because it usually I guess that's right. So, and then there's just a difference between quantities. So this is, let's say I wanted the TL082 CMX and OPB, no lead. So because the pinout, we already know what the pinout is, and we already have suitable schematic symbol, a suitable schematic symbol for that, because it's just a dual op amp. So let's just look at that. We have op amp. It's a little chaotic because this is something that has evolved instead of being designed. But if we look at op amp -D for dual, then there's an _0, there's an _1. This all happened when the libraries got converted over from the database library into the, so this just illustrates the process. Let's make sure of what the heck dual _1 is. Well, it looks the same, isn't it? No, the power pins are wrong on this, or well, they are not what they ought to be. I don't know why on earth that is like that. I guess that's, okay, that's strange. So don't use this in general unless you know what you're using it for. It looks like D_1 is the correct schematic symbol. That's strange. But again, this was something that was made a long time ago, and it's kind of gotten, at least these simple symbols have gotten grandfathered into our new system. So you can see that what do we want to see here? I mean, you can just check that the pinout is correct. Things to note: if you wanted to make a new symbol, this is, the way we've structured the libraries here with all the models. We have a new schematic lib file for every footprint or a schematic symbol, and the same for footprints. You may say that's really inefficient. We could just have one big schematic lib file and then put all the symbols into that. And that is perfectly valid, and you can definitely do that. The reason we've chosen to do it this way is purely for ease of version control. So because every schematic lib file is a binary file, and if you made a change to a single symbol, it has to change for Git to understand the binary. It has to basically just change the whole file. Whereas if you want to change just one symbol, it would be nice to change only one file of many. That's the basic reason why we've chosen to do this. It doesn't really change anything except that you end up with a whole bunch of discrete files. So if you wanted to create a new schematic lib, you go to File, New, Library, Schematic Library. And the same would be for PCB library. But today we actually have everything we need. So we have our symbol, and I'll show you that we have a footprint as well. If you go to Models, PCB Footprints, and it's a SOIC 8 or just SO-8. There it is. Takes a second to open. And here it is. So there it is. One thing that's worth noting is that the symbol or footprint name is the same as the file or footprint or file name. Now the name that actually matters is this one, is the one in like inside the file. I don't actually know if the file name actually matters as such, because it should. I don't know if it makes it like faster to search for the footprints, but by convention, just for simplicity and such, I make the file name the same as this one. Now, footprint names are not case sensitive. I don't know why, but they're not. So you can respect the case or ignore it. I don't recall if symbols are case sensitive, but I'm pretty sure symbols are case sensitive. So that's a nice little gotcha, I guess. So if I wanted to add this part, TLO82, it's an analog part, or an analog type of part. So I'll go to that sheet in Excel. I'll add a new row. And I know what this is, so I can dual, some dual set input kind of thing. What else is there to say about it? JSet inputs. There's a 4 megahertz bandwidth. Okay. Well, the voltage range is a nice thing to have on op amps. That's always one thing you're curious about when you're choosing a part. You're like, is this good enough? Or it can go up to 36 volts. What's its minimum supply? Does it even tell us? Should say it somewhere. Let's see. Supply. Well, we won't spend too much time here. I mean, it's going to be like a couple volts, right? So I'm just going to say plus or minus 18 volts. And sometimes it's nice to put the generic base part number in there in the description. But this one's so common. I mean, everybody should know what a TLO82 is. This one's going to be made by TI. Now let's check taking a look at the fields here, we have manufacturer part number, footprint reference, that's the name of the footprint. Library ref is the name of the symbol. So this is op amp D_1. That's easy to remember. Then two things that are nice to have, but obviously they change a lot, is price. Something that changes a lot less is the link to our favorite distributor, DigiKey. So let's actually get this on DigiKey. We'll try to do this quickly because it's pretty obvious how to go through this process, I think, but we want to get to some more interesting things, I guess. Got it's active. Well, let's just say it's active. They may not be in stock, but that's okay. I just want to get one in an SO8 IC. Okay, here's one. And that seems like a rational part number, for an 8 SOIC. So this will be our manufacturer part number. Oh, it even copied the format. No, I didn't want it to copy the format. All right, and the footprint is an SO-8, small outline 8. What kind of price are we looking at? $1.59. Okay. I usually go for the single single unit cost, just because that's more, it's more reflective of what we actually end up paying for our parts. We don't usually buy things in quantity. And that's about what you need. Make sure to save. The workflow then is, this is a bit of the annoying part. What I'm going to do is go to Tools and Offline Integrated Library Maker. You go to this, you go next, you choose your dblib, then you go through here and select which tables you want to regenerate the integrated library for. We only want to do analog. However, before we do this, we have to actually go into our file system and delete that table or that integrated library. I don't know if there's a way around this, like in some settings or somewhere. But that's the most annoying part, because you actually have to close Altium and then open your file system and delete this whole folder, then reopen Altium. Then we can generate it. Otherwise, it'll create a copy. It'll create a copy with like an _1 after it. Well, it won't be a copy. It'll create another integrated library, you know. And it's just annoying to change the name. So instead, I just delete from the file system. Because if you don't close Altium before you go to delete it, it won't let you delete it. So we've got just the analog table selected. We go next, and we let it think. I don't think it matters if this is open while you do this. This we'll find out. The more parts you have in the table or in the sheet, I guess, the longer this little step here takes. So this is it compiling the integrated library now. It's thinking. All right, we're done. Sometimes it'll pop up with some messages. In fact, there were some messages, whatever these are. Duplicate pins. Okay, I mean, that's not necessarily a problem. Yeah, messages can pop up. Sometimes it'll tell you like you didn't find the symbol because you typed it wrong or something. So those are good. And then we should be good. It'll add this integrated library now to your project, or your workspace rather. And you can just close that if you want. It also adds like, it adds all the files, it adds them to your workspace. So I've got a workspace specifically for that. Now, if we were to open some file, we should be able to go to components, go to analog, and there it is. It's a Christmas miracle, and it's there. So anyway, that's sort of the workflow for adding a single part. Of course, that didn't require any real work because we didn't have to create the symbol or create the footprint. But those are simple. I mean, that's just a matter of using the tools. Do you guys want to see an example of like creating a footprint, or anything like that? I see there's a check mark from Ben. Check mark from Zach. Okay, sure. So let's find some kind of funky part. I mean, the easy part, is creating this. Well, a lot of it just takes practice and a little bit of thought, I guess, because you don't necessarily want to rush through something and end up with a symbol that's really hard to use or a footprint that's bad. But let's get a part going. What kind of weird ass kind of some footprint we don't have, some kind of strange QFN or something. That's usually a good, like some of the hardest things you'll ever make are QFN or similar sort of leadless packages. You need to be careful about stuff. What's something, I know one, let's do a, what was it, the Max. Trying to remember just because this was a recent part I used. Let's see. One sec. See if I can't find this. Or we could do this one. This is not a bad part to do. See if we do, so we have that footprint. And if not, we'll do it. This one's going to be a TSOP. We do have two TSOP 20s. These days, I make much more descriptive part numbers for stuff. But let's look at this one. TSOP 20_0. Okay, that's pretty obvious what that was going to be. Look at it, _1. So what I'll do, you don't have this exact, it's unlikely when you have like exposed pads on a part. The part I'm looking at, I'll just pull it up as this guy because I used it recently. So this has an exposed pad and it's a TSOP. So that's, I think, a good representative example. So let's see. It's here. It's unlikely. Yeah, we don't have this part. That's good. Why does it want me to save this? All right, so here's the workflow. The symbol should be obvious enough, like to make. When I want to make the symbol, I'll go to Schematic Library. Save this as the name. So this is the LM2 25116. All right. So right now it creates a component called component 1. First thing I want to do is go over into the properties and rename this to be that with the designator and of course the undefined designator for ICs. I usually like to make the comment be the manufacturer part number. So when you want a field, like in your spreadsheet, if you have a field called manufacturer part number, you can then place that like an equal sign and then that. So if I wanted a piece of text here and I wanted it to be manufacturer, now when I place this symbol, it'll plop in the value for manufacturer into that text when I use the equal sign. So that's kind of nifty, but we don't care about that for this. So here, let's go make a rectangle. And I don't know how big it needs to be yet. We'll change the border color. I like blue these days. Then you'll go through and place your pins. So you hit tab, of course, to edit, designator 1. Okay, so I'm not going to do this and force you to watch. Some things to note, however, you can change the electrical type to be other things. I generally default to just passive, especially if it's some funky function, because this is used for like an electrical rule checking, which can sometimes be useful, but I've never actually had it catch any real problems. Most of the time it just complains about stuff that you're like, yes, I know, but I'm doing this on purpose. So like if you have two outputs connected together, what if you just want to do that to buffer something up? You know, it'll complain about that, or it'll complain about inputs being not connected, but you're connecting it to an output through a resistor. So things like that, I just don't find it all that useful. So I usually make things passive. You can change features of the pins, like you can make them shorter. You can change the location of text. You can change the size of the text, which can sometimes, when you're drawing like a little schematic inside of the component, it's nice to say, I want the name to be, you know, smaller so that it's not in the way as much. But the default is 10, which is usually fine. Okay, so then let's get on to the footprint, which is decidedly more fun. So the first thing you'll do is you'll create a PCB library. And you'll call it, you go in here, and you'll call it something reasonably descriptive. It's a TSOP, and there's 20 pins on it. And you mix up underscores and dashes and whatever, it's got an exposed pad. Let's look at this. Let's look at the dimensions of this so that we can, because what I'm going to do now is like tell it the dimensions of the exposed pad. Here, so the exposed pad looks to be about 3 by 4.2 millimeters. Yeah, 3 by 4.2 millimeters. So exposed pad, 3 by 4.2 millimeters. It's up to you where you want to put the units, or if you even want to put the units. It might also be worth saying like the pitch. We want to know the pitch because sometimes they're like 0.65 and sometimes they're 0.05. This one's a 0.65 pitch. So the pitch, not 0.65. Exposed pad, 3 by 4.2. So that's, I've taken to making more descriptive names for stuff. Let's go ahead and copy this because we're going to use it soon. What we're going to do now is we're not going to place every pad manually. We're going to use the footprint wizard. That'll only get us halfway because we still have to make the exposed pad ourselves, which is okay and actually good. So let's go. So you can see these are pretty descriptive, I think. Things like this, a lot of things end up falling under small outline packages. Not a lot of things, of course, there's quad packs, there's various other variations of that, which give you more options. Yeah, but we're doing a small outline package, and we're going to do it in metric. So then we get into the details straight away. So what is it suggesting to us? It's not always what you want, but what is it suggesting? This seems pretty reasonable, 0.42 dimension this way and the 1.78 dimension the other way. Okay. So let's just go with that. That seems reasonable to me. Then we get into this, which, a lot of data sheets don't give you that. You have to calculate it. This one does. It's telling you 5.94. And the pitch, of course, we already looked at, is not 0.65. The width of the outline, we're going to redraw the outline most likely, but 0.2 is a fine for the silk screen. And we're going to redraw it because there's going to be a pad in the middle that's in the way. But this is a fine dimension for that line. And finally, the number of pads. This is a 20 pad small outline package. This is where we copy the name of the file. That just makes it easy. We can paste that right in. That's what it's going to name it. And now you can see on the left, you have not only the default PCB component 1, you also have the new one. Let's get rid of this guy because now we have just our auto-created footprint. So there's some things to change right away. First of all, it's up to you to decide whether you want like a rounded rectangle like this, or if you want them to be plain old rectangles. It really doesn't make a difference. People will say that there's a difference with like the way traces enter a pad, and it's better to have it curved. But Altium actually has a tool. If you do care about that, Altium has a tool that allows you to make teardrop-like connections into pads. So just use that tool and don't worry about it. So in general, I like to make the pads all rectangular because I'm lame, I guess. Then there's a few other things we need to change. The first thing to change is your solder mask opening. You can see that this purple layer is your solder mask. These are the solder mask openings. And it's usually good to have them be a little larger than the pads, but you don't want them too large because then you get this little sliver of solder mask that actually is not manufacturable. So they're just going to chop that away anyway. But it's nice if you can get it. It's nice to have a little solder mask. It's nice to have a little solder mask in there. So you can see the solder mask expansion is a field. We're going to set it to manual. This reminds me of another thing. Before we continue, click anywhere, then go to properties. This will give you the properties so you can change your units to millimeters. I don't know why it didn't do that for you when it asked you in the footprint wizard, but whatever. You can usually cut this down to like 0.05 millimeters. And then you get a nicer, how much is that actually? So that's still probably not manufacturable. You know, like they'll still probably chop that away. Because if you look, it's about 0.15. Now, if you get green solder mask, they usually can make it slivers of like 0.1 millimeters. But other colors of solder mask tend to not have a smaller feature size. So your mileage may vary, but this is a good start. Also, at some point, it'll be nice, probably right now, to go to Edit, Set Reference. You want the reference to be the center. This is not only useful for us when we're making our pad in the middle, but it's also good for like pick and place centroid data because you want that. You can easily, you don't have to set like a pick and place reference separate from the part reference. So I don't know why they even put it up there, but they do. At this point, we don't. Our exposed pad, if you remember, we've got exposed pad in the middle. It's going to go someplace in the middle here. So we'll just, we at least need to delete these. And then you can do with this what you will. We can expand it out or something. I would really just redraw it. So we'll get to that in a minute. Oh, I just forgot. Here's the other thing we need to do with these pads. We did the solder mask openings, but now we need a paste mask opening. So the paste is, for those who are unfamiliar, the paste mask is that aluminum sheet that we buy from the PCB house, and they, with cutouts so that you can spread solder on really easily, or solder paste rather. It's usually the amount that's on there by default will be a little bit too much, and especially on a fine pitch package, it's going to tend to blob across if you leave it like this. So I also set a manual paste mask expansion of at least 0.05. And it's not more like 0.07 or something. There's really more paste there than you think, and the little bit goes a long way, really. But 0.05 should be okay. Then you can see how that it shrinks that opening to be smaller, and yeah, that'll definitely, it makes it so you don't have to go around and de-bridge all these components and stuff. And, okay, so then let's make our exposed pad. We go to place a pad. And of course, initially it's some through-hole thing, and it's got some default designator. The designator is 21. It's going to be one more than the number of ordinary pads you have. The type is on the top layer, and our shape is rectangular, and we have 3 by 4.2 millimeter pad. One other thing, well, basically, if you look at this, it's got this big cutout for the paste mask, but we would like it probably to not be so big. We'd probably like little squares of paste with sort of spokes in here, so that the squeegee thing that they use to spread it across, you know, is so flexible that if you didn't have like spokes in the middle of this, it'll squish down into the paste, and you know, it would scrape some away. And so I'll just show you what we're going to do. So let's go to our properties again. For our expansion, we're going to make it like -3, some large number. Now you can see there's no paste cut out. So we're going to add ones manually. So we're going to go to place, solid region. And somewhere in from the edge, you know, you're basically going to draw with some care, you're going to draw a little rectangle. Because it's worth noting also that the design person, whoever's designing the PCB, is probably going to put some thermal vias. So they might put one in the middle, and then one over here on the left and on the right, top and bottom. So that they'll get some thermal vias in there. And you don't necessarily want paste to go over those thermal vias. So let's actually make this global snap grid. I usually like to work on a 0.05 millimeter grid anyway. I just want to fine tune this a little bit. Let's copy this now using the center as our reference. Rotate it down, flip it. So when you're moving stuff around and you hit like X or Y, it flips it. In case you didn't know. Okay, so that's not bad. You know, these could even be a little larger. Like I said, a little bit of paste goes a long way, but let's just make these a tad bit larger. You just want to leave a little bit of spoke, you know, in the middle there, so the squeegee doesn't press all the paste out. All right, I'm pretty happy with that. Then the next thing is just add silk screen. And frankly, I don't really like what they have here. I mean, it's not bad, but let's see if we can't fix it up a bit. We'll probably stretch these to the edges like that. This, I think, could be bigger, like, I don't know, radius of like 0.5. There's no point in not having it be larger. Same thing down here. I'll stretch this out. Next, we just want a big circle. I'm partial to the circle approach of designating pin 1. And there's no rules here. You know, you just want to make it look nice and make it as descriptive as you need to. You know, so make it like 0.3. Yeah, that's big enough you can see it, but not so big as to be too big. Yeah, actually, I would make that a little bigger. Make that like 0.4. So you can sort of get a feel for how big this is as well. And that, the next thing is adding a 3D model, which we may actually have a suitable model already. It depends, because, so I store all the 3D models in the 3D models folder. However, you don't have to do that. I do that just for reference and for reuse purposes. But when you want to add a 3D model, let's look at this one, for example. The model is in Mechanical 1 layer. If you click on it, properties, you can see that there is a path for it, but I've selected embed model. So it's actually embedded it into the binary file. So it's not linked. You could make it linked, but I choose to embed it just because I don't want to have it linked. I just store the files there as a reference. But I want to look at, let's see if this is actually, this one probably, yeah, this one has a model. Where's this at? So that 5 point, that's close. This is a model that's probably pretty close. I mean, the model is just sort of a nicety. I mean, we're not mega precise about our models. And what I mean is, like, yeah, this model here will totally suffice. Now the question is, do we actually have it? When I migrated over from the old libraries, okay, we don't have it, because when I migrated over from the old libraries, a lot of footprints or models didn't make it. Maybe I should do that someday, go get them from the old. So what do? I mean, one option is we can definitely make them in SolidWorks. I've done that before, and that's fine. But a lot of kind people on the internet have in fact made these for us, made things for us. Let's find it. Okay. Have made things. So if you go to GrabCAD Community, go to Library. Their search function is honestly not great, but let's try it. Like, okay, so there's some people with some TSOP packages. I know this Single Fonts guy makes a lot of packages. Shout out Single Fonts guy. Let's see if these are any good. They look okay as long as they're the right dimensions. That's always kind of the catch, because there are multiple standards, sort of de facto standards for dimensions of TSOPs and such. So this might be it's a little hit or miss, but I just want to do this so that we can see how it works. Come here and now which one do we want? We want a 20 pin. So let's go ahead and copy that over to here. And let's place a 3D model. And you scroll to it and find the model. Hit the 3 key. Okay, that looks pretty good. I'm happy enough with that. Like, it's really just for, it makes your model, your exported model bigger, and the next team gets upset because there's 1,000 parts on it. And so there's always that. See, it's hovering over the surface a little bit. I kind of usually like to make it interact with the surface a little bit. I don't know if that's good practice or not, but if you let it hover like this, then when you export it as a step, it tends to complain because it's like a separate floating body or something. So I have it intersecting with the, I don't know if that makes a difference, but it's what I do. And then you have a very pretty little footprint. And at that point, of course, I didn't finish the schematic symbol. So if I want to actually add that, I would do that and then do the same process as we did for the PL082 to add it. And there you go. Some final notes on this. I usually don't like to use, like, I leave it up to the designer who does the PCB to do the thermal vias. I don't usually do those in the footprint, even when the data sheet recommends it. I always leave it to the designers because it gives you more flexibility with your drill sizes and flexibility of the precise placements in case something were in the way. It's just better that way. Everyone knows to add thermal vias to their exposed pads when needed. So I don't find it necessary or a good idea to add them to the footprint itself. All right. I think that's about what I got. I mean, that covers the whole, I think we covered all steps of the process. So this is, you know, making the symbol, making the footprint, linking them and, you know, logically linking them, and then compiling them to integrated libraries. Any questions about anything that we can answer here?
Is there a process to link the pads to the pins of the symbol?
Yeah. So that's all done by numbering.
Okay.
And it's actually, this doesn't have to be a number, but you can see every pad has a number. And you can see I made this number 21. So to logically link it to a pin on the schematic, I would need to place, you know, a pin with a designator called 21. The name of the pin can be anything. I would probably make it something like exposed pad, EP, but it's the designator that's important. And then that designator is what links it to the pad. You can see there's a field called designator. However, the designator does not have to be a number. You know, if I wanted, I could actually make this pad. This is a choice you can make. You can make the pad called like EP for like exposed pad. Then you would jump in here and make sure that your pin is called designator EP. That is totally legal. It's just a choice. You have to make that decision. Like if you want to reuse this footprint, you got to always know that the exposed pad is called EP. So I don't prefer doing it that way. I like the numbering. So I would do the numbering and similarly give this a number 21. Yeah, that's, but the linking when you do all the other stuff will happen by the numbering of, like you said.
Cool.
Yeah, that was something I hadn't been totally clear on. So glad you asked. Something in the chat. What do we have? Make sense. Sorry, what does that mean? It makes sense, or I should make more sense? Which I see. All right, sounds good. I'm glad it makes sense. Great. So that's, I think that's all I wanted to cover, and we have now it's now on the record. So with that, I think I will stop the recording.